Vishrup, you must start now.
Okay, sir. So, good evening, everyone. We are heartily welcome to you to this today's online professional hands-on training on advanced GIS mapping using QGIS. My name is Vishrup Bhattacharya, course coordinator of online certificate course on advanced GIS mapping using QGIS. First of all, I will introduce our organization. So, this program organized by Center for Environmental Research, Education and Development. It's a research organization of Hariharpur Friends of Environment Community. And this community registered under West Bengal Society Registration Act 1961 and Niti Aayog. So through this community, we organize several environmental education awareness camp, rallies, free health checkup camps, sanitary hygiene practice camps, tree plantation, waste monitoring, etc. So there, another hand, our CERED organization actively getting help from the Department of Geography, Hiralal, sorry, my pardon, Hiralal Bhakat College. The college is situated in Rampurhat subdivision of the district of Birbhum in West Bengal. And this Department of Geography is facilitated by well-equipped general laboratory and a remote sensing and GIS laboratory with proper internet connection. This recently, an ICSR funding research project was completed from this department successfully. Here we got Apurva Kole, Deputy Director of our CERED, Mosumi Pal, Academic Coordinator, who looking after finance, and Anona Chatterjee, Academic Coordinator of CERED. Surajit Karmakar, the technical support from we got, and from this online certificate course. Today, this class will be taken by Dr. Nalhati Das. He is an assistant professor in the Department of Geography of Hiralal Bhakat College, Nalhati. He was completed his PhD from Biswarthi, Santiniketan in 2017. He attends so many national and international seminars to contribute his research thought. He wrote several books on cartography in a Bengali version, which helps students to learn digital mapping through hands-on practice. He has keen interest in groundwater hydrology, digital mapping, and remote sensing. That's why he is now engaged to do research on different aspects of groundwater hydrology, and most of his research published on Scopus and Web of Science indexing international journals. His most recent research on COVID-19 pandemic and air pollution entitled by Asymmetric Nexus between Air Quality Index and Nationwide Lockdown for COVID-19 pandemic in a part of Kolkata metropolitan India has been taken by WHO in their database, and there have been lots of in this 2 days course. We have just first this today we will be cover our theoretical part, and then next we will be look after the practical session there. And I request to Dr. Das to take from here.
Okay, thank you, Vishrup, for introducing me, and good evening all the participants. Today I will discuss about the basic concepts of remote sensing and GIS, and tomorrow we will discuss about some practical part regarding the QGIS. So, as we know, we are living in a modern technological period, and technology is so many advanced today that we can do anything by sitting in our home. So likewise, remote sensing and GIS both are the modern and computerized technology which helps to create map, or which helps to plan more properly with the help of the different data sets. So first we will discuss about the remote sensing and remote sensing process. So what is remote sensing? So remote sensing basically is a kind of modern satellite based technology through which we can collect the data in any part of the world. So this is basically a satellite based technology through which we can collect both accessible and inaccessible areas data. So this is some definition of remote sensing. I will not tell you in detail because we have to cover a lot of things in this theory class. So if we see the application of remote sensing in present day context, we can see that remote sensing can apply it in different disciplines like geography. Geography definitely we apply remote sensing, but rest of geography, zoology, botany, history, and all other disciplines are now using remote sensing to collect the data. Like in agriculture, in water resource management, in command area studies, in irrigation water management, reservoir capacity evaluation, and so many things where we can apply the remote sensing technology. So now we discuss how remote sensing can collect the data from the Earth surface. So this is the entire picture through which we can understand how remote sensing technology collect the data of the Earth surface. So there are some basic steps or stages are involved in the remote sensing process to collect the data. So I will show you here. Participant, all of you are understand my language or understand my thought. Please response.
Yes,
okay.
sir.
Okay. So to do the remote sensing, some basic steps you have to understand. Like the first stage is the source of energy. Without the source of energy, satellite cannot be worked. So the source of energy is most essential and fundamental element of the remote sensing process. So in Earth surface, as we know, solar energy is the main source of energy. So if the solar energy is not present, then can we do the remote sensing? The answer will be yes. So on the basis of the source of energy, remote sensing can be classified into two categories. One is active remote sensing, one is active remote sensing. And another is passive remote sensing. And what is active remote sensing? First, we have to understand the passive remote sensing. When the remote sensing process has been operated with in the presence of solar energy, it is called the active remote sensing. When the remote sensing process has been completed with the help of the solar energy, it is called the passive remote sensing, because here satellite is act as an active machine, but the active remote sensing means when the solar energy is not present. For example, during the night time. So during the night time, when satellite are trying to collect the data, it collects the data with the help of the energy generated from the satellite sensor. Satellite sensor. So what is satellite sensor? Satellite sensor is a modern machine through which we can collect the data of the object. So satellite sensor, without the satellite sensor, we cannot collect the data. So in a satellite, we have to put a sensor to collect the data of the object. So in active remote sensing, when satellite sensor create energy itself, it is called the active remote sensing. So this is the source part of the source of energy, and here the solar energy coming from the sun, it is called the EMR. As we know in physics or in the optical physics, it is called the EMR, or in remote sensing science, it is called the EMR, or the full form of EMR is electromagnetic radiation. So the incoming solar radiation in the form of short wave, as we know, when the solar energy comes to the earth from the sun, the wave is short wave. So incoming short wave energy from the sun towards the earth, it is called the EMR. Is it clear to all? And it is called EMR because it has both electric field and the magnetic field. That's why it is called the electromagnetic radiation. And it consists so many bandwidth in a single EMR, like it consists short wave to long wave. and from short wave to long wave, it had so many segments, which is called EMS. That is, full form of the EMS is electromagnetic spectrum. Electromagnetic spectrum is the spectrum which is present in the electromagnetic radiation in different form of wavelength. Okay, in different form of wavelength. And what is wavelength? As we know, the wavelength is, it is a kind of wave where the wavelength is, we know that this part of a wave, it is called crest, 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 and the lower part of the wave is called trough. So the distance between two successive crest or two successive trough is called the wavelength. So longer the wavelength, create lower frequency. I repeat it, longer the wavelength, create lower frequency. So what is frequency? Frequency is number of wave passing through a particular place in a particular time or time. So number of wave passing through a particular place in a particular time is frequency. So wavelength? Wavelength is the successive distance between two crests and two troughs, and wave frequency is number of waves passing through a particular point in a particular time. So if the wavelength is larger, then the frequency will be the smaller, but if the wavelength is smaller, then the frequency will be the higher. So there is disproportionate or inverse relationship between the wavelength and wave frequency. Wavelength and wave frequency, there is inverse relationship. One is up and another is down, and this is the fundamental concept of the wave. Is it clear to all? Please respond if you have any question or if you have any queries regarding this up to this. Is it okay to all? Participant, are you? Am I audible?
Yes, sir.
Okay. So it is the fundamental concept of the wavelength, EMR, and now it is called the EMS, electromagnetic spectrum. So in a EMR, there are so many segments on the basis of the wavelength. It is called the gamma rays, X-rays, ultraviolet rays, visible rays, infrared, microwave, and radio wave. So among these spectrum, remote sensing basically use visible rays, infrared rays, microwave, radio wave. Visible and infrared both are used for the passive remote sensing. Microwave and radio wave used for the active remote sensing. During the night time, when a satellite sensor are using to collect, using themselves to collect the data, they create microwave energy from the sensor, or it can create radio wave from the sensor. So with the help of this microwave and radio wave, we can collect the data of the object even during the night time. But during the daytime, when the solar energy is present, then we basically use the visible rays, infrared rays to collect the data of the object. So this is all about the source of energy. So this is the first step of the remote sensing process, and the second stage is the interaction of energy with the atmosphere. Interaction of energy with atmosphere. Because when the radiation coming from the sun towards the earth, the solar energy have to pass our atmosphere. So when the solar energy passes through the atmosphere, it interact with the different elements of the atmosphere. Okay, please hold on just a minute. Okay, sorry for the interruption. So here we have that energy when comes through the atmosphere, it interacts with the atmosphere, and interaction means some energy has been reflected from the dust particle, some energy has been absorbed by the ultraviolet rays, some energy has been scattered from the atmosphere. So these types of interaction can be observed when it passes through the atmosphere. So these kinds of the interaction like absorption, scattering, then refraction, reflection, these 4 types of interaction can be observed when it passes through the atmosphere. So I'm not going to detail in this demo class. If you do the full course in the CERED, then you can get all this information in very detailed way. So when it passes through the atmosphere, some energy has been coming to the earth without affected by the elements of the atmosphere. This is known as atmospheric window. I repeat this again. Atmospheric window is the part of the atmosphere where the solar energy has not been get affected by the particles of the atmosphere. So this part of the atmosphere where the solar energy has been unaffected by the element of the atmosphere is called the atmospheric window. Is it clear to all? If you have clear about that atmospheric window and up to this, please respond me so that I can proceed very easily. I want to response from you.
Yes, sir.
Yes, sir.
Okay. Is it clear to all?
Yes, sir.
Okay. So then I proceed to the next stage. So after the second stage, I am coming to the third stage. The third stage is the interaction of energy with the surface feature. So this is the third stage where energy, the unaffected energy coming to the earth and it interact different object of the surface of the earth. Different object means in our earth surface, there are so many objects are present like vegetation, like water bodies, like soil, like bare land, like buildings. All the objects in the surface of the earth has been interacted by the solar energy. So when it interacts with the surface feature, 3 interaction can be observed, known as absorption and transmission. These three interaction can be observed in the remote sensing process when it interacts with any object of the surface of the earth: reflection, absorption, and transmission. So the energy which has been absorbed by the object is not functional for the remote sensing process, and transmitted energy also not functioning in the remote sensing process. Only the reflected energy is functional for the collection of the data in remote sensing, because this reflected energy has been recorded by the satellite sensor, but this absorbed energy and the transmitted energy is not recorded by the satellite sensor. So reflection interaction is very much important when it interact in any object of the earth surface. So reflection energy also vary according to the characteristics of the object. For example, if we take the ice surface and the sandy surface, we can see that in ice surface 100% energy has been reflected, but from the sandy surface major part of the solar energy has been absorbed by the sand. That's why not 100%, but for example, it reflect only 20% of energy from the sandy surface. So reflection character vary on the basis of the object. So this reflected energy is not same for the all objects. That's why the different reflected energy from the different object is captured by the satellite sensor, and it creates a curve which is known as spectral signature curve. Spectral signature curve. Spectral signature curve means differential reflection of solar energy from the earth surface create different signature. So different signature of the object, if we record it in a curve, it is called the spectral signature curve. I will show you how spectral signature curve appears to be. This is the spectral signature curve, and this one is for the fresh tone. You can see this index. This is for the dark tone. So in this way, of that, we get energy in different way. So recorded energy in the sensor in different way has been recorded in a term of curve which is called the spectral signature curve. Is it clear to all?
Yes, sir.
Okay. Do you have any query up to this? Anyone having any query up to this?
No, sir.
Okay, the things is not complex, it is very simple, but you have to understand in simplest way. So this is the third step we have just completed. Now the fourth stage is interaction of energy with the atmosphere again. What does it means? It means the reflected energy from each object has again interacted by the elements of the atmosphere. When the reflected energy from the Earth's surface from the different object are interacted with the atmospheric elements, it lost some data of the object. I repeat, when the reflected energy from every object interacted with the Earth's surface, it lost some data of the objects. And after getting reflected from the atmosphere, in the fifth stage, the data has been recorded by the sensor. In the fifth stage, the data has been recorded by the sensor. So in satellite sensor, what kind of data we have recorded? We have recorded the reflected energy data in the sensor. What reflected? The reflection from each and every object of the surface of the Earth we have recorded in the sensor. So after getting recorded of the energy, the sixth stage is, I'll show you, the transmission of the data to the concerned station. I'll show you here. This one is the fifth stage, and the sixth stage, I'll show you that in the sixth stage, what happened in the stage 6, collection of data by the station. Which station? The station who operate the satellite. This station is called GRS. This station is called GRS. What is the full form GRS? Ground Receiving Station. And the example of ground receiving station in India is present in ISRO. So ISRO collect the data of the satellite, and then in stage 7, just a minute, I just have a call.
Okay, I would like to request all the participants that if they have any queries regarding today's class, they can ask sir immediately after the topic, or they can ask after the class also in the question answer session. So I would like to request all the participants to get ready with their questions. Thank you.
Again, sorry for the interruption. So now what I'm telling that GRS, about the GRS, ground receiving station. So ISRO is a kind of ground receiving station where we can collect the data of the remote sensing, and they provide the data to us. And after collecting the data from the ISRO, we what we will do? We do processing of the data, preparing new map, and planning different type our plans. So this is all about the process of the remote sensing through which we can collect the data, how we can collect the data, how we can transfer the data to the GRS, and how GRS provide the data, and how we can use the data. It will be the discussion of tomorrow. So up to this, I think it is clear to all. Is it clear to all up to this? The process of remote sensing, how we can collect the data and we can get the data. Is it clear to all? Participant, are you here?
Participants are requested to respond.
Please respond.
Yes, sir.
Okay. So now regarding this, I'm telling us about some satellite data. The satellite data which you have collected from different concern station. I just tell you some of satellite data like Landsat data, the popular data, and like lease data. So Landsat data basically is the data collected by the USGS, United States Geological Survey, and the satellite using by them by NASA. So NASA provide the satellite to collect the Landsat data. So Landsat satellite means the land use satellite. So the data of the Landsat basically used to prepare land use map and other types of different NDVI maps, NDWI maps, all other map we can prepare from this Landsat images. So Landsat is not a single image, but it has mission. It is called the Landsat mission. So in Landsat mission, there are up to date 9 mission: Landsat 1, Landsat 2, Landsat 3, Landsat 4, Landsat 5, Landsat 6, Landsat 7, Landsat 8, and Landsat 9. From the Landsat 8 to 9, only Landsat 6 data is not available to us because Landsat 6 mission was failed due to some technical error. So we cannot get any data of the Landsat 6, but rest of data we can get available from the USGS Earth Explorer website. I'll show you. So this is the history of the Landsat mission. It's a very short history I'm telling you. The Landsat and it is started around 1980s to 2022, and recently Landsat line data is available from the mid of the February, I think, and it has launched last year November. So Landsat 9 data also available to us. And coming to the point of the lease data is provided by the ISRO. So it is a pure Indian data, and the data has been provided by Burdwan. So Burdwan is the associated partner of the ISRO. So Burdwan basically provide the data of the lease and data collected by the ISRO. And it has also a mission, that is that up to this 4 missions are available: list 1, list 2, list 3, and list 4. The data of list 4 is not freely available, but the data of list 1, 2, 3 are freely available. Now I will show you where we can get the data of the Landsat and from where we get the data of the list. I will show you in my computer. So to get the data of the Landsat, go to the Google and write it down here: USGS Earth Explorer. We have to write it here, USGS Earth Explorer, and go to the homepage of the USGS Earth Explorer. So before downloading the data, you have to register in this window, because without the registration of this portal, you cannot download or you cannot get any data of the Landsat. So you have to first register here with giving some detail of your or giving up some of your personal detail or academic detail. They will register you, and then you can get the data from here. So this is the website from where we can get the data of the Landsat, and you can not only the Landsat but all these data like the aerial imagery, like the commercial satellite, like the digital elevation, that is called the DEM. It's called the DEM, digital elevation model. Then we can get the data of the Landsat, and you can see it here that Landsat 9 data, I think. Yes, here 9 data also available here. 9 data, all these 9 data are available now here, and you can get the data of the Sentinel image. Sentinel image is also a very high resolution image. You can get it from here. So this is from where you can get and right now VN. And in Bhuvan portal, it is the portal of the NRSC, National Remote Sensing Center. So in Bhuvan portal, if you go to the data set here, this option, open data archive, all of you are able to see it here.
Yes, sir.
Yes, sir.
Okay, if you open the data archive, you can get the data of the satellite, you can get the data of the digital elevation model. So digital elevation model is called the Cartosat here. Cartosat is a DEM provided by the India, and in satellite you can get the data of the list 3 here. So if you want to get the data of the list 3, you have to select the tiles over here, tiles, TILES. So you select the tiles over here. You just select the tiles over here. Yes, just like that. You can select multiple tiles by pressing the control button. You can select multiple tiles, and then you can get the data from here. By clicking on next, you can get the data from here. So this is the data you have collected from the different portal like USGS, like Bhuvan, etc. Is it okay to all? How you can collect the satellite data? So I am telling you about two types of satellite data. One is called the Bhuvan, and another is Landsat, and another is called the LIS. Is it clear to all?
Yes, sir.
Okay, so now I am finishing talk about the remote sensing. Now I am going to the another part that is called the geographical information system. I am not going to the detail because the detail is not possible within one day, and you cannot get all this detail within one day. So if you do the entire course or full course in our institution, then you can get all the detail and hands-on in you by sitting in your home. So now I am going to the part of the geographical information system. So geographical information system, basically a computer-based system where we can collect, we can gather, we can store, we can analyze all types of data. Both it may be the primary data, it may be the secondary data. So geographical information system is a modern computer-based technological system where we can store, gather, or analyze different types of data, and we can prepare a digital mapping from here. So in present day context, whatever it is, whatever discipline, they apply the remote sensing GIS technology. Like in economics also, they are using the geographical information system for the proper planning and management. And in geography, as we know that without GIS we cannot do anything in geographical research. So in history also, GIS is also an important branch there, because in the archaeological survey they are trying to identify the ancient feature or the archaeological feature from the satellite image, and it is only possible in the GIS environment. Okay, geographical information system. So GIS is a technological based or information based system where we can do all these things with the help of the different data. So remote sensing What is the difference between remote sensing and GIS? Remote sensing is the technique of data collection, but GIS is the analysis of the data in the computer technology. Is it clear to all what is the basic difference between remote sensing and GIS?
Yes, sir. Yes.
I'm telling you again that remote sensing is the satellite-based technology for the collection of data in any part of the world. But the geographical information system is a computerized technology where we can analyze the collected data from the remote sensing. So remote sensing data can be processed or can be prepared map with the help of the remote sensing data in GIS environment. So this is the basic difference in remote sensing and GIS. So now, what kind of data basically used in the GIS technology? It is very important to understand. That GIS basically deals with spatial data. It is very important term in GIS technology, spatial data. So GIS cannot deal all types of data, but GIS you have to convert the data into the spatial data. So what is spatial data? The spatial data is a kind of data which has been expressed with the help of X and Y coordinate. In GIS, longitude is called X and latitude is called Y. So latitude, spatiality or without the XY coordinate system, GIS cannot handle the data. So what I'm talking, are you able to understand? The participant, are you able to understand what I'm talking?
Yes, sir.
Yes, sir.
Okay, so you have to collect or you have to convert the data into spatial data to work with the GIS environment. So why now the question is why X is called longitude and Y is called latitude? I'll show you why it is called. We know that this is the X coordinate and this is the Y coordinate. And if we look at the longitude, we know that the longitude is like this perpendicular shape. So we can see that if it is 88 degree, then it is 89 degree, 90 degree, 91 degree, 92 degree, like that. So longitude is increasing or decreasing along the x-axis. That's why X is called longitude. And if we look at the latitude, then we can see that latitude increased or decreased along the y-axis. So that's why Y is called the latitude. So in this way, X is considered as the longitude and Y is considered the latitude. And X and Y coordinate data is called the spatial data. So without spatiality, we cannot do anything in the GIS environment. So let's understand about the elements or the components of the GIS. GIS have the 5 components, which is called the hardware, software, data, method, and people. Hardware means the computer technology. That means the CPU, that means the CD-ROM, that is the keyboard, that is the mouse, monitor. All these things are the hardware part in the GIS system. And what is the software part? Software means in which software technology we create the map. As we know, different softwares are available in the market. So some softwares are licensed version or some software are open version. So what is the difference between the licensed version software and open version software? Licensed version software means you have to purchase that software from a company, like the ArcGIS, like the ERDAS Imagine, like the TNT MIPS. All these softwares are paid software or licensed software you have to purchase from a company. But the open source software, it means that you can easily download from the website, concerned website, and you can use freely for your lifetime. So these types of software is called the open source softwares. And QGIS is the one of the important and one of the very recommendable open source software we are using now. So if you are working with research work, or if you are working with an article writing, if you are writing article ArcGIS software or ADAS imaging, the reviewers or editor can ask you to give them the license. But if you are using QGIS software, then there is no question of asking of any license or asking of any paid software, etc. So that's why if you are using any open version software, you are free to use it, and you have to now give any answer to any authority or any higher authority or a reviewer or editor. So this is the basic difference between the paid software and the open software. And the data, as we said, that GIS basically deals with the spatial data and also deals with the non-spatial data, but there is some conditions apply that how we can use the non-spatial data in the GIS. You have to hands-on the fundamental course of the GIS. So the fourth option is the method. So here method refers to in which method we analyze the data, in which method we present the data, and people, that means users. So if you are preparing a map, how the people or the users how they can use that map, and how they can implement the map for the assessment of the society, for the welfare of the society. This is all about the components of the GIS. Up to this, it is clear to all?
Yes, sir.
Okay. Do you have any question up to this? Any question, any query from your side?
No, sir.
Okay. So now I am going to the another data set of the GIS. One is called the raster data and another is called the vector data. This is also the part of the GIS data. So what is raster data? The data having the pixel and having the different DN value, it is called the raster data. If we show you how raster data can be look like, you can see it here. This is the raster data. If you zoom in a photograph, you can see the box like this. If you zoom any satellite image, I'll show you in the software. Just a minute, I'll show you in the software. Just a minute. What is raster data and vector data? I'll show you. Are you enjoying the class?
Yes, sir.
Okay. So tomorrow I will show you how QGIS look like, how we can download the QGIS, and how we can use different tools and techniques in QGIS. It is not possible to show all these things in one day, but I will show the major part of the QGIS. If you remember it, or if you want to do courses from our institution, you can do it, because in the March of 19 a course will be started regarding the advanced QGIS. You can join that course and you can learn about the application of the QGIS software in the advanced mapping and advanced application of QGIS. This is one of the satellite image of a study area. So if you zoom over the satellite image, can you see some boxes are appeared in the image?
Yes, sir.
So these boxes is called the pixel. So what is the full form of the pixel? The full form of the pixel is the picture element. So this pixel actually representing the aerial coverage of the specific area. For example, this box has a specific width and height. So this is the Landsat image. So in Landsat image, I will tell you that in Landsat image, spatial resolution of the pixel is 30 meter. What does it means? It means if it is a pixel of a Landsat image, then the width is 30 meter and the height is 30 meter, and the area between them is 900 square meter. Is it clear what I am telling?
Yes, sir.
So one pixel covers 900 square meter. So if we look in the QGIS, that this pixel covers 900 square meter. So this is a kind of raster data. But if we have the vector data means vector data is a kind of spatial data, and it is represented by 3 geometric shapes. Vector data has been represented by 3 geometric shapes. One is called line, another is called point, and third one is called polygon. When we preparing a map from a raster data, we are using this kind of geometry to represent the vector data. So how vector data works, I will show you in a hands-on. I will show you now, because tomorrow it will be very difficult to solve these things. Suppose this is a toposit map. All of you know about the toposit map.
Yes, sir.
Anyone from the rather the geography background, having environmental science or other discipline?
Yes, sir.
You are
Yes, myself.
from which discipline are you? Satishji, from which discipline are you?
Yeah, myself, Satish Kumar J, and I am from environmental science.
Okay.
I am from.
So though you have environmental science, but you know about the topographical maps.
Absolutely. Yeah, absolutely. You know what is Tapur.
Okay. So if I want to prepare a map of this dam, can you see this dam? If you want to prepare a map of this dam, you have to create a vector layer, or you have to create a vector data set to making this dam separately. How we can create this? I just creating it here. I'm not telling the detail to you. I just creating here. Dam. I'm writing the name dam. And here I am selecting that. You can see that the dam is representing an area. Is it or not? Dam is representing basically an area. So to acquire an area, you have to create the polygon. So here I am creating the polygon shape. If you select the geometry type, you can see that the polygon is here. Can you see it here?
Yes, sir.
Okay. Just select the polygon and click on OK. Then if you want to prepare a vector data, you can just make a tracing. I think all of you have the knowledge about the light trace.
Yes, sir.
So this is a kind of light tracing method, but I am doing it digitally. So yes, I'm doing it digitally. So this digital tracing method is called the vectorization or digitization. So if you have digitized it and switch off this topographical sheet, you can see that a separate layer has been created of the dam. Can you see it here? All of you can see it here.
Yes, sir.
So this is the vector data, and if you zoom on the vector data, you cannot find any pixel from here because vector data has no pixel. Vector data has only three format. One is point, another is point line, and third one is polygon. So if you are creating a layer of area, you have to take the polygon. But if you have to, if you want to create this, digitize this roadway, you have to take the line feature or the line geometry to identify the road. So I'm also showing you the how you can identify the road here. I am identifying creating a road layer. Road. So separate layer has been created by using this vector layer. So you have to identify the geometry as line and click on OK. So if you want to digitize this road, you can just digitize it from here. If you switch off this topo sheet, you can see that a road has been created. So you can create separate layers for the road. You can create the separate layers for the vegetation, for the forest, etc. So if you are doing research regarding the forest cover, you can have the topographical map. Then you can trace the forest in this way. You can digitize the forest in this way, and you can see this data over the Google Earth also. You can, if you want to overlay, or if you want to superimpose this data over the Google Earth, you can also make it here from here. How you can do this? You can open this Google Earth in this in the QGIS window. Can you see it? The Google satellite has been opened it here. So this, are you able to see this? That Google Earth window has been opened. I am opening here.
Yes, sir. Yes, sir.
So you can justify your feature with the help of the present context. So if you see that the dam is now dried up, the previous dam has been dried up here. You can see that most part of this previous dam has been dried up, and the dam basically extend over here. So this is, you can from this way, from in this way, you can create a temporal changes all over there. So if you want to work with the migration of the river channel, you can also create a map of the river from the topo sheet of previous year, and you can superimpose your previous river map with this present satellite image, and you can clearly justify how the river has been shifted and how much kilometer river has been shifted its original position. So in this way, you can do anything, or you can do any types of research in GIS environment. So this is the best part of the software, or this is the best part of the QGIS software, because it is freely available to you and you can use in lifetime. And the best part of this software is all the tools and version are updated in every month. So you can get the updated version in every month. You can get more and more advanced tools and techniques to create advanced mapping in the QGIS software. So I request you to join the full course of the advanced QGIS, and you can learn lots of things in that course, and you can learn the basic and the advanced thinking, how you can advance your research, how you can get advance your paper, and you can make your paper more visual or more attractive in this way. Is it clear to all what I'm telling?
Yes, sir.
So okay, so therefore this is the data part of the GIS, what I am telling now. So you can easily get the overlay analysis in GIS. You can see it here that this is the layer of the road. Second one is the layer of the building data. Third one is the layer of the forest data. Likewise, this you can see it here that this is the road layer. Can you see this layer panel here in the left side of the window? In the left side of the window, you can see the road as a layer, dam as a layer. So whatever layer you are adding in the QGIS, you can see in the left side of the layer panel. So in this way, you can superimpose or overlay all these layers in a single frame, and you can justify or you can compare the temporal changes of different layer or temporal changes of different elements from the past to present. So in this way, you can work with the GIS software. So this is the one data handle I am showing you. The next part of the handling data is the satellite data handling. So if you are working with the satellite data, you can just add the satellite data in the QGIS software. And you can change the color of the map. So in this part, I am telling you satellite on the basis of the satellite color. Satellite data are of two types. One is called the true color composite. Sorry. One is called TCC, and another is called FCC. What is the meaning of TCC? It is called true color composite. And FCC is called false color composite. What is the difference between the true color and false color composite? I'm telling you that true color composite means the exact color of the object. The exact color of the object. If we look over it here, if you see, this is the true color of the object. This green color representing the cultivated area. This green color with this blackish color representing the eutrophicated pond. This is representing the fresh pond. Do you understand all these things?
Yes, sir. Yes.
Okay. So this one representing the vegetation, the green vegetation. So this is the true color of the image. So this is called the TCC or true color image. But if I am using this type of color, like if I change my color, you can get this kind of color. So here the red color representing the cultivated area and this blue color representing the built up area. So actually the vegetation is the green color, but in the satellite image we will show it through the red color. So when the actual color of the image is represented by the another color, it is called the false color composite. So now the question is, why we are using the false color? We are using the false color because to identify the object very clearly and properly. So why we are using the red color in the analysis of the vegetation? There is a logic for the using of red color in the vegetation, because in a plant we know it has the chlorophyll content. So chlorophyll basically reflect the infrared rays or the infrared energy, and when the infrared energy of the vegetation recorded in the satellite, the vegetation color appear as red. So if there is any variation in the red, it representing healthy, the vegetation is healthy, or the vegetation is sparse, or it is a forest, or it is the agricultural land. So the color of the infrared or the variation of the red color basically tells the truth that is whether it is the agricultural land or it is the forest cover. If you see it here, you can see that this light red representing the cultivated land, but the deep red, if you look at over the deep red, I am showing you this one. This one is the deep red. Can you see this like blackish red? This one.
Yes,
Yeah,
sir.
yeah.
So if in a satellite image there is a blackish red, it means it is a forest. If you want to sure about that, you can just open the Google Earth here. You can see, just look the actual image. Can you see this? Can you see this, that it is a vegetation in real ground?
Yes, sir.
Okay, but if we look this lighter red, this one, then you can see that it is a cultivated land. You can see this is the cultivated land. You can see the pattern of the land of the agriculture. You can see it here. Is it okay?
Yes, sir.
So in this way, by using the false color composite, we can identify the vegetation. And also, if you want to try, if you are trying to identify or separate the land and water properly, if you are trying to separate the land and water properly, I am using another false color. I am showing you that. I am using another false color to identify or to separate the land. And I will tell you what is the combination. So in this combination, you can see the water is prominent over here. Can you see that the water has been is prominent now?
Yes, sir. Yes.
And your land is also prominent now. This is the settlement area, and this is the water bodies. You can prominently distinguish between the land and the water. So in this way, we are using the false color composite to identify the object clearly or to prepare a new map from the satellite image very easily. So this is all about the satellite image, the data of satellite image, and how we can collect the data from the satellite image through different satellites, and how in GIS we can process the data. So this is the theoretical concept I am giving you. So now it is open for the question and answer. You can ask me any question regarding today's topic or regarding any topics of remote sensing and GIS. You can ask me any question regarding today's topic. Do you have any doubt? You need any clarification? Please tell me. Please tell me the band combination of water and land studies. It is the band combination of 7, 4 and 2. 7, 4 and 2. This band combination you can get only from the Landsat image. In LIS image, you cannot get several bands. That's why the band combination in LIS image is very small quantities. Or any other question? Is it live data or any years? Okay. Jaya Kumar case, you asked me about the data is live or any year. You can download the data of any year. I'm showing you. If you going to the Earth Explorer, can you hear me? Jaya Kumar, can you hear me? Okay. So you can see that suppose if you want to download the satellite image of Sundarban area, this is the Sundarban area, you just click 4 corner of the Sundarban. You just click.
Sir, it is not visible.
Oh, sorry.
Please share your screen, sir.
Sorry. Is it visible now?
No.
Yeah.
Okay. If you want to, suppose anybody want to research with the Sundarban and its degraded forest area. So if you want to get the images of 1990 and if you want to get the image of 2022, So you have to select the four corner of the Sundarban. You just select it over here, and then if you want to take the data of 1990, you just scroll down, and here you can get the calendar. Can you see the here the calendar, data range calendar?
Yes, sir. Yes.
Okay, just select here the year 1990 and try to get the data of cloud, try to get the cloud free data. Try to get the cloud free data. So to get the cloud free data, I am taking the month January 1990, 1st January 1/1/1992, 31st December 1990. I am taking this range, and if you want to remove the cloud from the satellite image, you just click on over the cloud cover. Can you see the option cloud cover? You just decrease this cloud cover range 5%, 4%, or 0%. You can also make it 0%, or I am taking it 2%. Then you go to the data set. Click on the data set. What kind of data I am taking? I am taking Landsat 7, 8, 9 data was not available in 1990. I repeat it. Landsat 7, 8, 9 data was not available in 1990. You can get the data of Landsat 4, 5, 1, 2 or 3. So just click on Landsat 4 to 5 data, just check in this box and click on this result. If you click on this result, you can get the preview of your available satellite. You can see it here, that in your left side, you can get the preview it here.
Yes, sir.
So your next task will be whether your marked area are covered by the satellite or not. So there is an option, it is like a footprint option, like the foot, a symbol of foot. Can you see it here, symbol of foot? So if you click on symbol of foot, you can see that your area is slightly covered. Basically, this satellite image is over here. So you cannot take this and take the next one. It is also not. Then next one, yes, it is covered, entirely covered your area. Can you see that your entirely covered the area?
Yes, sir.
So now you can click the show browse overlay icon, that is the image icon. If you click on over here, you can see the preview of the image and clarify that is there any cloud or not. You can see that there is no cloud. It is a very clear image. You can work with very properly. And the image of the date of this image, you can see it here, 14th of November 1990s. Can you see it here? 14th November 1990. This data is for 14th November 1990. So this is the cloud free data. So you can now download it. So before downloading, you have to log in with these browsers. And if you are not logging with the browser, this downloading option was deactivated. So this option is only be active when you are logged in with your proper registration ID. Then you can get activate this icon and then click on download. If you click on download, it will show ask you the product option. So here each and every band you can separately download it. That band 1, band 2, band 3 you can separately download it, or you can download in bulk way by clicking over here. Can you see this large size option over here, 377.33 MB?
Yes, sir.
So if you click over here, the data has been automatically downloaded in the left side of your window. You can see if I click over here, the data has been downloaded in the left side corner of your Google Chrome window. It will take a minute to download. So to download the satellite image, you have the proper and speedy internet connection, and you have the large volume of data. So you can see that the data is now downloading in the left side corner of the Google Chrome. Can you see this? Participant, can you able to see this? That data has
Yes, sir. It is downloading.
Okay. So the data has been downloaded in the zip file or WinRAR format. Then you have to extract the data and then you have to work with the data. So this is the method to downloading the data. And any more question, please explain how we can retrieve maps. How we can retrieve maps? I don't understand. What do you mean by retrieve maps? Are you want to prepare a new map from the old map? Okay. Any
Sir,
more? Yes,
Sir,
yes.
how do we alienate the study area in any map, in any given map, or in a Google map? How we can alienate our study area? Suppose I want to, particularly, I want to choose some particular area from. I want to earmark a boundary. How to do that, sir?
Okay, understand. Okay, I'm showing you in QGIS that you have an study area like this. Can you see it, Satishji?
Yes, sir. Yes, sir. Yes, sir. Clearly, sir.
So you have this study area, but you have the India map, but you want to extract only this part. Is it or not?
Yes, sir.
Are you asking?
Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes.
Okay. So you just want to mark this area. I'm highlighting this area. Hold on. You just want to get only the area under this boundary. Is it or not?
Okay. Yes, sir. Yes, sir. Yes, sir.
Okay. So this process of extracting of your map by using your boundary called mask, M-A-S-K, mask. So how we can masking that image? Here there is an option in the raster. So here there is an option extraction. Can you see it here, extraction?
Yes, sir. Yes, sir.
So you can click over here, clip raster by mask layer. So when you're clicking over here, you have to give two data. One is called the input layer. Input layer means the raster layer. Here I am masking raster layer using the vector layer. So this is, are you understand that I am masking the raster layer using the vector layer?
Okay, sir. Okay.
So the toposit map below is the raster layer, but the red area is the vector layer. So I am here masking the raster layer using the vector layer. So in the input, I am giving the raster layer, and mask layer must be the vector layer, Nalhati municipality boundary. So you do not have nothing to do here. You just click, or you can save it in a folder. I am save it in a temporary folder and click on run. You can see that the area has been masked.
Okay, sir. Okay, got it.
You can see that the area has been masked.
Yes, sir.
And if you want to remove the black background from below, you can just do it from transparency, give the value transparency 0 and click on OK. You can get this one. Can I answer your question?
Yes, sir. Yes, sir. Yes, sir. You answered, sir.
Okay.
Thank you, sir.
Any more question? Actually, Satish sir, actually, if you do the full course, you can get all these things from this course.
Okay, sir. Okay, sir. Let me see.
And new course will be started from the 19th of March. And this course is regarding the advanced QGIS mapping. And you can do, you can get the syllabus from the coordinator. You can get see it, and if you are wish to do it, you can do.
So, what is the fee structure and anything? Anything can be shared?
Structure and all are provided in the brochure. So we will provide the brochure to everyone. There you will find the fee structure, date of registration, and all the details regarding the course, sir.
Okay, madam. Okay. So you'll be sharing in the WhatsApp group. Huh?
Yes, in the WhatsApp group as well as we will mail it.
Yeah, yeah. Thank you. Thank you very much.
Okay, any more questions? Okay, so I am ending this session and hand over to this session to the Ananda.
Yes, sir, I'm here. Okay, so thank you so much, sir, for such an informative session. And I hope all the participants have benefited by today's session from today's session. They have learned many things, I think. So anybody is having any question, any queries regarding today's class or the upcoming course, they can freely ask us. We will answer them. Anybody is having any question regarding the course? Okay, I think I should give a brief about the course. That will be better. So our upcoming course is the mainly online certificate course on advanced GIS mapping using QGIS, and this is a course which is a joint initiative by Center for Environmental Research, Education and Development, that is CERED, of Hariharpur Friends of Environment and the Department of Geography, Hiralal Bhakat College. Now, this is a course of 2 months, and this is a certificate course for 2 months. It is from March to April. We will conduct this course from March to April, 2 months course. So it is mainly based on GIS mapping in different study areas like climate change, land use and land cover mapping, watershed mapping and analysis, preparation of geological map, preparation of HP model for groundwater potential zones, animating maps in QGIS, and many more. Completion of this course successfully will help the participants to get 2 credit points. And on successfully completion, participants, they will receive a scorecard also and also a certificate. Now, as this is a 2-month certificate course, and this course will be, the classes will be mainly conducted on the weekend, that is Saturday and Sunday, so that all of the participants can easily do the class. So altogether, we have 16 classes in 2 months. Now, the course registration we have already started, and the last date for registration is 15th of March. That means this month, 15th. So, and many more information regarding these courses is provided in the brochure. We will mail the brochure to all the participants who are present here today. And also we will provide the brochure and the syllabus of the course in the WhatsApp group. So if anyone is having any queries regarding the course, they can go through the brochure also. And then also if anyone is having any problem regarding the course, or they want to know more about the course, they can freely contact us in our given contact number, which is provided in the brochure, or they can mail us also. Mail ID is also mentioned in the brochure. Okay, so participants, if you have any problem regarding the course, if you want to know more about the course, they can freely contact us. We will always help the participants to understand the course properly. Okay, so
another thing I'm telling you that I will be not available tomorrow on 6 p.m. So tomorrow the class will be started from the 7 p.m.
Yes, sir. Yes, sir. Yeah, yes. So tomorrow's class will be from 7 p.m. Right, sir? Okay. So any more queries, anything? I will request participants, if they have any queries, anything to ask, they can ask us. I think no more queries, sir. So thank you, sir, once again for such a nice session, and thank you all the participants for your cooperation. So tomorrow again we will have the next part of this training. So participants are requested to join the class on the scheduled time, that is on 7 p.m. Thank you. So we are ending our today's class over here. Again, we will meet tomorrow at 7 p.m. Thank you, sir.
Thank you.
Thank you. Thank you.
The participants.
Sir, will the certificate of this course be useful in future?
Definitely.
Yes.
Definitely you can use.
It will this course will help you to get 2 credit points Okay, that means after the completion of the course, you will be getting 2 credit points.
Okay, ma'am.
Okay. Okay, sir. So we are
Okay, I'm
ending
leaving.
our session.
Okay, I'm leaving.
Thank you all. Thank you all the participants.